Good morning, my very good friends. It's Roger once again, representing that university, and today we are in for an exceptional time. Now, I have done Uluru many times. That is also known as Ayers Rock. Apparently, that was the guy that discovered it and decided that he would name it after himself. However, the Aboriginals know it quite well for quite a long time as Uluru. Uluru. And it is their sacred mountain. And we're going to get into this in great detail. Right? In the past, all the things I've done, I have to do them in a couple of minutes because everybody's rushed. Well, no, you got a little time on your hands, I would imagine. If you do, you do. If you don't, you don't. But if you'd like to look at this in the depth that it will now be presented, that's fine. Because it's going to go a little long, as all my videos will from now on. And I want to also say a couple of other things. I've been getting told, well, you showed that before. Well, of course I showed it before. Nobody paid attention. None of this stuff is being spoken of in reality. Nobody's speaking of this as a heart. That's a heart. That is a heart. I can absolutely, positively guarantee, and if I can't convince you of this, I don't know what to say. Because I have the evidence that is unimpeachable. Nobody can deny what I will show to prove what I can prove. And you can also get proof right from the source. So this is going to run long, and we're going to start off by understanding a little biology. Now, everybody likes biology. Well, I don't know if everybody does, but it's an interesting subject. Let's go that route. Biology, geology, all that stuff. That's why they say, oh, you got to learn all that. Well, they don't teach it correctly. I mean, biology maybe to some degree, but a lot of the stuff that's being taught about biology can go a little different direction, I think, and that's what I'm going to show. And all of the stuff I'm showing is going to go a different direction from what you're being told in school. So when you go back to school, maybe you can mention, this is what this guy's saying. What do you think? All right, so let's start from the biology. Let's look at this, because this was absolutely fascinating. This is by Dr. Jean-Claude Guimberteau, and it's called Strolling Under the Skin. Now, this goes back to 2014. This was very early in my research of the fossilization process that I had discovered. And then I realized it was fascia that was the thing that caused everything, hold on, to separate from everything else. That's a human lung. It's always been DNA certified. I've shown it a million times. I know you showed this, you showed it to us. Well, I did, that's correct. And I'll show it a million more times until somebody pays attention. Now, this is what happens, and that is the fabric, and that is fascia. And all of these things seem to separate out as according to their, like even this is a heart. We're going to go, as again, Uluru is a heart too. This is a heart. We're going to go over this, and I have many examples of this. Wait do you see? I got a bazillion of them in my research. But even the big, like fingers and everything. The finger, see, that's a big finger. That's a little finger. That's what it is. This was with DNA certified. That one hasn't, but it's a finger, and that's where the blood blows out at the end. I have a ton of this stuff. So let's watch this. This is absolutely fabulous. Strolling under the skin. Now I'll cut in every now and then. She's just
The story of this film began
wonderful.
about 20 years ago. We were transferring vascularized turkey tendons in our university research lab, and were struck by the intricacy of the vascular network.
You see that? You see this? This is what's called synovial sheaths. And hold on. This is a tendon under here, and they have to slide in here. And this is also a tendon. Believe it or not, that is a tendon, and that still is the synovial sheath. I was doing this. Tyson found the same stuff, the tendon, and he's got the synovial sheath on it, but his is like not selenite. This was in a condition where I believe it was a lot of salts, and they take everything out and they leave the structural stuff, and that's the slippery selenite. I'm sorry, the slippery. They call it small leucine-rich proteins, and it's this slippery synovial sheath. So, and you have to slide through. All your tendons have to slide so smoothly through you. And actually, here, the funny thing is, one day I'm looking up coefficients of friction. I don't know. And synovial joints, that's what I'm talking about right now. Their friction is almost nothing. It's like way less than even Teflon on Teflon. It's 4 times lower than Teflon on Teflon. So we have to, and now, bringing that up, you have to be fluid inside your body. And that means you need some oil. I use castor oil. I'm not kidding you. You know, the oily substances in your body is what allows your fluidity, motion, everything to move freely inside of you. And, you know, I don't recommend anything specific, but, you know, oily substances, they call them, I think they're like long chain carbon molecules. You know, castor oil is, I think it's 18 carbons in a chain, and on the 12th carbon, as I recall, there's a hydroxyl group, which is it's a molecule cracker. And what happens is it can set up a bunch of different little, they call them fatty chain molecules, and they're a little slippery. And at a certain point on a number of carbons, they get slipperier. At a certain point, they're a little sticky, and then I can't remember the numbers of the discs. I think it's like around, I can't remember. We'll get into it maybe, who knows. But let's see what she has to say about the synovial joints, the synovial sheath sliding in these tendons. Let me back it up a little bit. I tend to run on, but I don't care anymore.
The story of this film began about 20 years ago. We were transferring vascularized turkey tendons in our university research lab, and were struck by the intricacy of the vascular network. Thereafter, the Chinese School of Plastic Surgery discovered the notion of the retrograde flap, and we began to develop a technique for transferring vascularized retrograde tendon flexor transfers onto the cubital pedicle to get round the problem of reconstructing flexor tendons. Little by little, this new vision of anatomy began to throw light on the relationships between the tendons, the sliding sheaths, and the vessels, and to challenge the very foundations of the classical school of thought. During the revascularization following the release of Agarrett, we observed that not only the tendinous extremities bled with an apparently circular longitudinal and peripheral vascularization,
See it, look at it.
in contradiction with the avascular theory that held sway at that time, but that there seemed to be a real continuity between the sheaths and the tendons, which was not interrupted despite the distension occurring during sliding.
All right, you hear what she's saying. They really didn't understand this stuff at all, even up till this point, 2014. And when I was in 2012, when I found the first mud fossils, and I realized it was fascia, I started to contact people. Nobody knew anything about fascia, really nothing. The only guy that knew anything was Gil Headley. And this guy is fabulous, Gil Headley. You should look up his autopsy. I sat through a bunch of autopsies that he did, and he explains every little bit of everything. And when I first contacted him, he was calling fascia fuzz. You see this little fuzzy looking stuff? And in his videos, he talks about it, how that is the stuff that glues you together. literally. And he talks about how you have to stretch and do this and that and how you move, and how he takes his finger and he pushes through the fascia on these cadavers that he's doing autopsies on. And he says, if this doesn't go freely, you're glued together. And that's what I was just talking about. So all these things will come back to me, and I'll sort of blurt them out as we go along. And again, this is going to go long, but that's just the way things are going to go.
It was also clear from observing the behavior of the vessels of the common carpal sheath during flexion and extension that rather simplistic mechanistic explanations could no longer account for these phenomena, and that this apparent disorder and irregularity of shapes was in fact the basis of some other form of complexity that we still knew hardly anything about. In our attempts to find an explanation, we began detailed in vivo microscopic analysis of the distribution and mobility of the vessels using 25-fold video magnification. By looking at a vessel as a petrol pump, we were able to approach the problem more simply. There was this vertical structure looking like the main part of the pump, then the pipe, and finally the adjoining vessel, just like a car filling up at the gas station. The pipe seemed to move away as the car moved off and to fold up as it approached. Look at this sequence. A large vessel, vessel 3, is gradually moving behind vessel 2 and the pump during flexion, then goes past it while approaching vessel 1, which in fact is the car vessel, whose pump is slowly receding as the pipe extends to its maximum. Finally, vessel 3 has overtaken vessel 2 and has closed on vessel 1, which itself has receded from vessel 2. So several forms of speed and progression seem to exist in homogeneous living matter. Due to the influence of reductionist linear thinking, the only rational explanation used to be that vascular structures were reinforced by several coaxial layers of connective tissue.
The number of layers of tissues is absolutely staggering. There is literally thousands of layers where we used to think there was one or two. I'm not kidding you.
Closest to the tendon moving the fastest and the furthest away moving the slowest. However, that view of annular layers sliding together needed the existence of a hierarchical histological distribution to stand up to scrutiny. Yet in vivo observation made the notion unacceptable. This meant that we needed a new way of thinking, something posing...
All right, you see that's the stuff that they call the fuzz. And when they operated, so they just knocked it out of the way. I mean, really just, and they threw it away and stuff. And that's fascia. And that is literally the connection to every single cell in your body is touched by fascia. Every single cell in your body. Now, at this point, I'm starting to think it is the actual connections that the bacteria use to get to these cells when they have to go. Because I've now discovered that bacteria not only is resident in your gut, it just stays there and it lives there. Well, it does. However, it appears that on command, it can leave the gut and go somehow through some network to the cells that are the tumor cells that are invading. They, at that point, and we're going to go through this is fabulous, they go through the cell membrane, and the membrane is like a blanket. And it says, you can't get through here unless you got a key. And he says, yeah, I got a key. He said, what's the key? And it's got a code, and then the blanket goes, and the code goes, and the blanket goes, and that's done. No more going through. Hopefully this is going to stir some really intelligent young minds, because this stuff is fascinating if you let it get, if you can get it presented to you in a way that it makes sense, and it does make sense. As you can see, I'm hopefully I'm making sense. If I'm not, tell me I'm not. So here we go. This is the fascia. This is the fuzzy stuff. And she's saying we have to have a whole new way of looking at it. And yes, they do. Because again, nobody knew about this stuff, even up till about 2014, 2015. The Germans, I was talking to some Germans, but they were all associated to pain because of the gluiness that can happen of this. And that's where you get your pain. And that's why castor oil, you rub it on these spots that are very painful. What it does, it literally invades this stuff with these slippery molecules. I'm not kidding you. And it goes into the skin, and we've had a lot of success with that, castor oil on the skin, and it helps the sore muscles and stuff. All right, here goes.
The problem in terms of global dynamics, continuous matter, a theory involving the concept of a tissue continuum, in total contradiction with the traditional view of sliding structures.
Here, let me go
Briefly,
back a second.
the notion of stratification.
Here. But she's going to explain that they had no clue as to how these, and they still don't, I don't think. I mean, the things in medicine work at a glacial pace, and in all sciences. If you present anything, it will linger, and it will not be accepted. That's just the way it works. No matter how much backup you have, it's the people that are in power make the rules, and that's just in every part of society, really. So maybe that'll stir another little spark in some young minds.
This meant that we needed a new way of thinking, something posing the problem in terms of global dynamics, continuous matter, a theory involving the concept of a tissue continuum, in total contradiction with the traditional view of sliding structures. Briefly, the notion of stratification and virtual space.
You see
In
how
vivo
fine
observation,
the
or
web
with
is?
electron microscopy after dehydration, showed that this collagen network in fact formed continuous matter composed.
You see that? That is the layers of tissue. When you compact those, they turn into layer after layer after layer after layer. It's absolutely amazing. And this is an electron microscope, so this is as way down as low, I mean as high magnification as you can get.
Composed of billions of tiny disorganized vacuoles, apparently arranged in a fractal manner. It was pseudo-polygonal, but with a very special dynamic forming of volume of glycolicin, whose surrounding was composed of type 1, 3, 4, or 6 collagen fibers of considerably different sizes, according to their anatomical location and the role they had to perform.
See how
In this chaotic
intricate?
haphazard world, there was absolutely no geometric regularity, no linearity, just
All right, you see that? And they claim, and I don't know if it's true or not, but they're talking about there's a possibility that is the network, all of those little fibers. So I guess you would have all kinds of multiplexing there. You know, in other words, instead of like one wire running to one cell, you have a network of so much intricacy there, and they can use any road. It's like the highway system of the country, and you have to get from LA to New York. Well, you don't have to go one road. It might be the best way to go, but if you don't go, that road gets cuts off. Well, you go somewhere around, and I guess that's what the way the body works. Because I think this is the highways to all the cells. I mean, it's just too much intricacy to be just accidental.
This system is customarily known as the connective or areolar tissue, but we called it the multimicrovascular collagenic absorbing system.
It has to stretch and
To
give.
our minds, it was a...
All right, think about it this way. In order to continuously be attached to something, if you're moving around, all kind of different distortions, jumping and you know, all kinds of things, bending, and they have to rubber-like behavior, plastic-like behavior, but they still stay attached. Those things are communicators. In my world, I'm going with communications on that.
rubbery elastic system because its role is to avoid reaching a threshold of resistance at which the collagen might shear. It has to allow the tendon to move freely without transferring the movement to the surrounding structures. It also struck us that the biomechanical behavior of this shock-absorbing system could be accounted for by the theory of drawers. As the tendon moves, the first vacuole might undergo traction to a point where it triggers the adjoining vacuole into action. Then the third is triggered, and the fourth, to such an extent that the final vacuole remains almost inactive. Our second hypothesis was that the same process was involved, but that the pressure was distributed equally among the vacuoles. However, this meant we were still only in 2 dimensions and that our only explanation was based on linear processes. Yet we were sure of something. The tissue continuum, the existence of basic vacuolar-type structures, and the presence of a shock-absorbing system, allowing the organs to act independently. We had to move to 3 dimensions to really understand what was happening.
I'm going to talk to you about interstitium shortly, which is how the skin and all your tissues can, well, mostly it's the skin, so it can slide apart and then come back and reform to its exact original orientation. So you stretch this way, there's 6 different ways, and it comes back. Now, as you get older, like my skin, it doesn't come back as well. But during youth, when these fibers are very reactive, then and if you can, and these are collagen fibers they were talking about, collagen 1, 2, 4, and 6, something like that. There's like 25 different collagens and keratins and keragens, and there's all kinds of different biology in your body that allows to construct different fibers and fabrics and bone and eyeballs, and I mean there's a million different tissues in you that have to all work together. Absolutely fascinating, exquisite, intricate.
And it was around that time that computer-synthesized images came online. They made it possible to visualize structures as a system in perpetual motion with 2 rigid boundaries, a fixed external one and a fully mobile internal one. What we did was to introduce a cross-linking mesh-type architecture which included the microvacuoles on the armature. We then looked for the fractal distribution. The scientific approach and the graphic model pointed to the same apparent reality. There really was a sliding system with brilliant liquid lying between the vacuoles and an armature of collagen fibers. This confirmed what we had initially thought about the pulling and tugging going on between the vacuoles. Moreover, thanks to this discovery, we were able to confirm that not only the tendons were able to move independently from each other, entire organs could do likewise, so the system was common to the whole organism. It was then that we realized what we had discovered. This multi-microvacuolar collagenic absorbing system was to be found everywhere.
The world isn't black and white. There's no set path.
Skip ads.
In the body.
It's everywhere in the body, she said. And it is. Everything is connected to everything else.
To be found in every nook and cranny of our organism. In other tendons, like the extensors, in the abdominal wall near the rectus abdominis muscle, in contact with the thorax near the latissimus dorsi muscle, in the retroconjunctival groove of the eye, and so on. Indeed, it would seem that this tissue serves to anchor the muscles and tendons, and could even be their primary constituent material. Even structures not called upon to move as such, nerves and the periosteum, are composed of this tissue fiber, but with differences in their arrangement and size.
That's a very important statement. They also are connected, but they don't have the stretchiness. They have these blockiness looking things, but they're still connected.
The mesoscopic framework of living matter required a more holistic view to be fully understood. So we began to look at the cutaneous and subcutaneous structures, which we thought we would find to be more stable in this mobile tissular environment.
You have to be completely
By its structure and its role of enclosing the other sensory organs, the skin is more than just an organ. It's a set of organs which is anatomically, physiologically, culturally, and psychically complex. Of all the senses, touch is the most fundamental. You can survive without smelling, seeing, or tasting, but not without touching. The skin permanently relays information. It never shuts down, blocks up, or sleeps. It has an odor, a texture, it perspires, secretes, eliminates. It exchanges signals with the outside world. Thanks to the skin, the body's surface is as much a machine for communication as a protective barrier.
just below this is the interstitium. All of these, there's like a bazillion straps, and they're all squiggly, and they have a ball attached. And the ball is the anchor. The skin can do this, all this squiggling around, and then when it's not stressed anymore, it comes back, and it comes back to its original form, because these little springy things inside are springy. That's the nature of collagens and keratins and keragens. They are the fabrics. Now, they wear out. And I'm looking into how to replace that fabric, and I think I might have a way. Well, I'm not going to talk about it right now, but I found some things that make some statements that make it sound like there's a way of putting that springiness back into there. We'll see. I don't know. I'm old enough where I can try to see if it makes me spring back in. All right, here we go.
It can change color, texture, and shape, and retains the vestiges of aggression, such as sunburn, scars, and disease. At birth, it is taught, ready for life. Then, little by little, it ages, gets wrinkled, folded, and sags. Whether in newborn babies, adolescents, or adults, the skin is never totally flat and smooth.
All right, let me show you something, then we'll go back into this. Okay, here you have the skin. They call it the mucosa. It's just that's that skin bumpy layer they show you. Now, here's these interstitium balls. This collagen bundles, that's the collagen fibers I'm talking about. And then these positive lining cells, whatever, these are the anchors. These are the interstitium balls. And they have straps, and the straps run around in little, see, squiggly things that run around. This is not really that well represented. Normally the ball is anchored, and then you have a lot of squiggle going on, and that bag fills up the same way every time, so it gets back to where it's supposed to be. These lines are a lot bigger than what they're showing here. Now, and these are the fluid-filled spaces. So you need to be hydrated. You need fluid in your body, and then you need the oily substances that are the molecules that are slippery, and then everything will work correctly. As you get older, like I said, they get saggy, and these straps don't stretch right, and it's just like anything gets old and tired. Okay, now you know that I do the soft tissue fossils. These are those little tendon balls. You see them? They're all over the place. And then there's all the straps running through there. This, as you go up, is in the cornified skin, and then the layers right underneath. It's a webbing of fibers that everything is anchored and it returns. Now, of course, as they get solidified, and this is a cut slab, it's hard to make out exactly what the construction was, but I can show you the construction on Mars. Okay, so you know that I talk about giants all the time. These are the interstitium balls. I'm sorry, that's what they are. That was skin. That is the creature's organs of some sort. I'm not sure what they are. These interstitium balls are on top of the basement layer of tissue. And this layer of tissue has eroded, and there it is right there. It's called mud. It's a red clay. It's body clay that's eroded from the interstitium balls. And every single thing there is I can find in the universe right now, I'm sure, is all biological. Now, let me show you what this is on Mars. It's the same stuff. You see that? They call those the Mars blueberries. That's the basement layer. That's the same thing you just saw on the last picture. And now I'm going to show you when they still have the straps attached, because Mars doesn't erode the way Earth does. All right, this is interstitium, and this is where the skin is pinched together. This right here is where it's stretched apart. Same thing here, same thing there a little bit. pinched, pinched, stretched, stretched. The straps have eroded because, see, they're stretched out. That's what happened to your skin. Same thing happened to your skin. And then that would go zip, go right back. Well, it's not going back because whatever it was attached to is now dead. Now, I don't know about, the size of these creatures were gigantic, just like on Earth. I mean, it's the same thing. What this is like sandblasted. There apparently is not a lot of watery erosion on Mars. Obviously, they say there's no water. Well, they found now that there is some water. Okay, you know that I understand biology, and I understand how it fossilizes, and I understand giants, and I understand the chemistry, and I understand that that is an artery. And they call it the Mars crab. This is arterial vascular network that goes out to feed all of this. See, it's this thing right here. And they expanded it to show it here. It's feeding all this muscle. And as that blood runs out of the muscle, it forms red, dust. It's really just blood. It's the same kind of mud as we have here, only there's no real watery stuff to go along with it. But it erodes away and dusts away, and and here it is right here. It's all this red stuff is blood, or tissue from eroded out of the muscle. Let's go with that. That's blood. Now, this is the vascular network that feeds all this. I know this extremely well. That is the return artery. They run together. One of them has no legs going into, because it's a return. This one here is feeding. That's the artery. Okay, so we know about this, and there is my specimen right here. It is virtually the same thing. These are all the fibers of the muscle, just as you see right there. And I actually have, right over here somewhere, I believe the blood vessels are coming out on a very similar look. It's obviously not exactly the same piece of muscle, but you can see all of the muscle bundles and all that stuff. This is what it is. And again, this is the top layer. This is where the skin would be. Very tough stuff on the top, and then it goes down below and through all that other stuff. Now, of course, the interstitium balls you can't see in my stuff. Now, I don't know for sure, but I would suspect that maybe those blueberries are down in this area, because there's probably some interstitium ball somewhere around here. I would suspect either that or this is a deep muscle layer, and that could very well be too. Because interstitium mostly is underneath the skin. It's the skin return layer. Okay, we're going to see a lot of this on Uluru, and you're going to see a lot of these cavities like that and all these little corpuscular holes inside. That's because there is a tremendous amount of fibrousness in there. It's doing a ton of this. Okay, I believe this is inside of a heart, and that is either a ventricle wall or one of the muscle fibers that contracts the heart. Okay, this is the type of fibers that we're seeing at Uluru, and we're also seeing the wrap around the outside as it comes down around. Okay, there is that fibers, and that's the texture of it. Now, we're going to get into this deeply because it goes miles deep into the ground, and this is the Alexander ND Traveler video drone footage. It goes 8 minutes. Excellent. And there's other ones. So we're going to get into this very deeply. But before I finish this today, I want you to get a little other perspective, because this is History Channel, and everybody knows a History Channel, and this is their interpretation of Uluru.
Uluru Rock, also known as Ayers Rock, is located nearly in the center of the continent, over 1,200 miles from the nearest major Australian city. This geological anomaly is one of the largest isolated rocks in the world. It is over 2 miles long and rises over 1,100 feet. It is, in fact, the exposed tip of a huge vertical slab of rock that continues below the surface for 3 miles.
It is a huge sedimentary boulder that's gigantic, sitting there in the middle of the desert. And geologists cannot really explain how Ayers Rock came to be. It's
All right, I can explain it, and I am going to show it, and think I can prove it beyond any shadow of a doubt. And I understand all of this. This is all muscles. So I'm going to get into this I have so much on this, and so much on what happens to muscle as it solidifies, as I've shown you. And my stuff is not guesses. A lot of things I'm showing are certified in a number of ways. And DNA is one, and I have 3 different DNA tests, and I have giants of absolutely extraordinary size that are the DNA certified as human. And anybody wants us to test this and say that I'm wrong, that's fine. And I don't feel like I'm exposing anything to anybody, because there's so much of this stuff all over the earth that I don't have anything special at all. The only thing I have special is the understanding of what it is. And other people have the special ability to disregard what they see. So we're going to get deep. All right, I love you. And as far as the Big Bang goes, to get that right out of your head, this is nothing that happened from a Big Bang, trust me. And everything that was written, start reading here, if you could get a hold of something like this, mythology, encyclopedia of mythology, that's where your real knowledge is. I'm sorry, that's just a fact. And if they can't get over that, I don't know what to say. If you're going to school and they're teaching you that this is nonsense, again, I have no words to comfort you. Okay, back to the strolling under the skin.
With any movement, they immediately align themselves with the traction. Their former position disappears and a new shape is adopted. Then, as if by memory, they return to their initial position.
That's the skin.
With every single daily gesture, be it a caress or a fall, the skin undergoes this form of translation, traction, and stretching. Yet, with the exception of open wounds, it returns to its initial position. Of course, this movement has been known since time immemorial. It's called elasticity. But the question is, how is this elasticity linked to the subcutaneous structures? With the aid of a video endoscope, we began to stroll around under the skin to try to understand this apparently simple word of sliding, mobility, and smooth, slippery surfaces. We wanted to find out how it could accomplish both fast, sometimes violent movements, and gentle, minute ones without the slightest jerkiness. Dissect with a surgical blade, and what do you see? Just a wealth of tissue connections, a histological continuum, without any clear separations between the skin, the dermis, the hypodermis, the vessels, the aponeurosis, and the muscles. How is it then that this can all move so smoothly, and how can sliding come about? When you look closer, you can see that just below the dermis and hypodermis, there's a highly mobile tissue encompassing everything else and penetrating what is known as the undermined plane. When this tissue is tracted upward, you get a surprise. Curious movements occur due to the bursting of vacuoles at atmospheric pressure, demonstrating the existence of hydraulic systems under different levels of pressure. The show is total with pseudogeometrically shaped fibrillar structures encompassing the muscles, skin, and fat. Yet what are these shapes? What do they do and why are they there? Is this what we have traditionally termed the connective tissue? Let's now delve into this world of fibrils.
This is really what I usually refer to as the areolar tissue. It's areolar, and it's well, you see what it is.
Initial scrutiny reveals basically two types of structure. Some are quite wide, with edges like knives and diaphanous surfaces. These surfaces are made of glycoproteinous derivatives. Others resemble longitudinal fibrils, which may be fine, long or short, swollen or cylindrical. At first sight, they look alike. But look closer, and you can see tremendous diversity. Birds' plumage, reed stems, bundles of rushes, ears of wheat whose resistance to traction is considerable, ropes, rigging, harnesses, with rings that reinforce the solidity like an articulated bamboo stem, transparent sails, dewdrops. Travel along these pearly structures, and you notice the same fractal arrangement everywhere. Large fibrils endlessly punctuated by other smaller ones. The tissue continuum is total, the marriage homogeneous, and the arrangement completely fractal. A world of fibrillar chaos. The human body...
Think about this. Everything in you has to be communicate and be coordinated. Let's think about coordination of your movements in your body and your thoughts related to your emotions. Well, obviously you see something, so you have to process the sight of it, and then you have to reach out and grab the thing, and all of that stuff is body commands. I mean, it may just happen spontaneously, but if you don't see the thing, you can't grab the thing. And if you didn't see the thing, and then somehow it's got to process, is that the thing I want to grab? So there's a lot of interactions, and I think this is the network that is the communications network in the body. Now, electronics is something that you have circuits where your electricity flows through and your data flows through these different circuits. However, this is so extremely integrated with such an enormous bundle of fibers, and it appears that they can reroute themselves. I would imagine that's the reason for this complexity, that it's what's called parallel processing. Right? That means that you just don't have one wire running down to the thing. You got a bazillion trillion wires. So if you have to have 10,000 million instructions coming down here at one instant, they've got 10 million thousand different fibers. So you don't have to have them go one by one by one by one by one. They go parallel, bam, and then instantly you snap your fingers. Right? That's the way I'm seeing life.
Body would seem to be one and the same tissue that has differentiated over time, but whose basic organization is stereotyped. Yet this organizational framework supporting life must have its inherent rules of behavior. How are these structures organized? How do they resorb and move, and what role do they play? To use the jargon of physical mechanics, the arrangement can be termed a complex one, completely stable and in search of equilibrium. A system with tremendous capacity to resist and adapt to change. For physicists and doctors alike, there is no other such entity with so much cacophonous movement on the microscopic and macroscopic level. Movements involving the muscles, fluids, fibrils, and cells. Here...
Now don't forget, these are little tubules. Things can pass inside of those tubules. I'm almost 100% certain. They're not just there as one big solid strap. Now, recently I have discovered, and I know I've said this several times recently, and I'm going to say it again, the bacteria in your body is your health. That's your immune system. The bacteria. and they create enzymes. And the enzymes create, well, the enzymes themselves are literally chemistry. They're nothing more than a certain arrangement of chemicals designed by that bacteria to do a specific job, and they get sent through these fibers. Now, this is what I'm suspecting now. This is the highway that they can follow to get to the cell that is damaging a tumor cell. They go right into that cell, and they go through a mattress, they call it, the cell mattress. And if that bacteria has the right code, it's called a toll. It has a toll receptor. These are the toll receptors. And if it has the correct toll, it says, okay, you got the right thing. He says, yeah. And he's okay. And then this thing goes, and it gets to a certain size that accepts that particular thing. It goes, zip, and gets inside, and opens, closes the pathway, and no more invasion into that cell. Well, now that bacteria is in that cell, and it creates enzymes. And the enzymes are the products that do the job. And that's what's in these. All right? And it says they're enzymes. It's always going to be the enzymes or the raw bacteria that creates the products that kill the things that are in these tumors. They actually go in and kill them. That's what I found out. Now, if anybody can fight against that, I'd like to know how they can fight against it, because the new research is very, very compelling.
Here we are at the very heart of complexity.
Well, you're not kidding.
A Capernaum of collagen bathed in glycolicin with reservoirs of fatty microglobules storing energy, information, and matter. A communications network for exchanging energy, matter, and information between the component parts of the system and the various reservoirs by way of a torrent of blood rushing between the nerves, veins, arteries, and cells. Some mechanisms are still poorly understood, such as the fluctuations in pressure, visible in these images of the movement of drops within a filament that is clearly hollow.
There you go. Clearly hollow. Look. Bacteria going up to kill a tumor.
There's even more to the story. Within this global network encompassed by the skin, you also have valves able to increase or decrease the flow of information in terms of intensity and speed. Storage times play a leading role here in amplifying or inhibiting other mechanisms, with a direct consequence on fat and lymph reserves. This multi-microvascular system, which at first sight seemed chaotic and complex, is therefore a set of elements with a large number of non-linear interconnections and arranged with a universal aim in mind: to promote life, to subdivide, to multiply according to preordained criteria such as the level of oxygen, the temperature of the body, and the composition of the plasma. This internal state of equilibrium must be maintained at all cost. Yet this internal equilibrium comprises another essential aspect: the maintenance of the structural equilibrium in terms of mechanical stability and not in terms of flows or transmitters. In order to transmit, the structure must be able to resist, to adapt to basic environmental requirements, and to maintain its architecture.
You know, I just got to make a statement now, because it's just too overwhelming. Life itself. For anyone to think that this is the product of some explosion of dead dust that has no affiliation to life, has no processes built into its structural integrity, its knowledge base, its way of presenting itself to the universe. It has nothing. It's just floating around. And by all of these things banging around together, they just all congealed, and this is the end result. For that mind to teach others to accept that, to me, is I just can't even imagine that mindset. It's just unbelievable to me. And it is wrong. It's 100% wrong. And all of the things that flowed from that are wrong. Every single bit of it. So that's what I will always tell you. You know, I'm going to tell you what they say and what I say. There was no Big Bang. This is 100% life. The universe is from some God, some creature that we will never understand, and that we will have to accept as the creator of all of this. And then I follow the stories that are told about the Titans and about all the rest of the stuff coming down to us now, and about what we have to do to try to, you know, do what we can to be good human beings, and hopefully that'll get you into the next realm. And I'm telling you right now, I am 100% sure at this point there is another realm, and it's good or it's bad. So I'm looking for good.
Sequences demonstrate the existence of pseudo-geometric shapes with a polygonal distribution. This visual impression is the most simply expressed in its basic element, the microvacuole. We've already seen this with regard to the peritendinous system. It is composed differently according to the dynamic role it is called upon to play. The greater the longitudinal travel, the finer and more repetitive the form of vacuolar organization. However, the basic composition of a polyhedric fibrillary network filled with jelly remains the same. The bottom line is that the network must ensure its own total movement without disturbing anything else around it. The dynamic has to be absolute and the shock absorption immaculate. These two apparently conflicting roles must also be accompanied by the spring-back memory function, while saving on energy and heat expenditure.
Okay, I think we've gone deep enough into the fascia and the way the body tissues move around and the blood flows and the fluidity that is required within the body. And you've seen some of the structures, and so we're going to go forward. And I was going to do the whole thing today. I don't think it's going to be possible because I have so much to go over about Uluru and its biological significance. I'm going to show you it in such great detail that there will never be a question as to its true identity. All right, let me just wrap up a couple quick things, and then we're going to do another one that's going to be extremely long. Now, saying that, it's going to be extremely long. I want your input. Tell me, is that okay? Do you like, is the long ones good or bad? Should it be like a 5-minute or just a quick, here it is, have a nice day, which is what I did in the beginning. I said, here's your Uluru, it's a heart, see you later, and that's what it was, and everybody just laughed. So I think it might be beneficial for everyone to take some time to look at this in its trueness. Not just dismiss it out of hand, which is what's been done right now up to this time, and dismiss the DNA tests and CAT scans and anatomists and specimens, and they're all been thrown aside. So I think it's time, and you're going to be the ones that are going to have to get this out to everybody else, because I've said this a million times. I am under restrictive controls. I can guarantee you that. I do not. I was actually contacted by the email. I don't know, whoever does our email. It said, be advised, you shouldn't send anything to people that don't want the things that you send to them, because they're going in the trash. So maybe that's why nobody's responding, but nobody does respond. And I have 80-something thousand people on my site, and I only get a couple thousand hits, and they're all the same people every single time. You know, not every single time. I don't know who's watching it, but there's only a couple thousand hits, and that's on 80,000 people that are subscribed. So I know I never get any coverage anywhere other than people that know of me. So if you don't alert people to me, it's just me and you. All right? So the next video is going to be very, very long. But let me just wrap it up by showing you what I'm probably going to show you. Just a quick hit on it so that you'll drool until I get it out there.